So let's look at this side first, the one that says factors and multiples at the top. It's also the one that's on the board. It has the squiggly border around it. So the lesson we're learning today is all about factors and multiples. Well, what is a factor? What is a factor? Carla?
Factors are two factors that are multiplied together to get a product.
Good. So factors are the parts of the multiplication problem that you multiply together. For example, we have the number 32. Well, we know to get 32, we have to multiply 1 times 32. So you can imagine a little multiplication symbol there. 2 times 16, or 4 times 8. So what that means is that 1, 2, 4, 8, 16, and 32 are factors of 32. Those are all the numbers that you can multiply to get 32. Can you multiply 3 by anything to get 32? Think about it. What's 3 times 10? Victoria? 30. And what's 3 times 11? Aaron? 33. So if 3 times 10 is 30, and 3 times 11 is 33, can you multiply anything by 3 to get 32? Class?
No.
No. So that means 3 can't be a factor. What about 5? Can 5 be a factor, Cullen?
No.
No. Cullen, what's 5 times 6?
30.
30. And what's 5, what's 5 times 7?
35.
35. So 5 times 6 is 30, and 5 times 7 is 35. Can 32 be a factor of 5? What about 6? Can 6 be a factor of 32? Carla?
No.
No, because what is 6 times 5?
6 times 5 equals 30.
And what's 6 times 6?
6 times 6 equals 36.
So if 6 times 5 is 30 and 6 times 6 is 36, can 6 be a factor of 32?
No.
No. There's nothing you can multiply 6 by to get 32. What about 7? Can 7 be a factor of 32? Can 7 be a factor of 32? Thank you, Carla, but I want to get somebody else. Kingston? No. What is 7 times 4? 28. And what's 7 times 5? 'Come on, Kingston. Gotta be practicing. We're going to start the drills again tomorrow. For anybody who has not gotten an A yet. Which everybody's going to take it. But I'm only going to score those who have not gotten an A yet. So it'll be practice for everybody who's already gotten an A. Kingston, what's 7 times 5? I can't hear you. 35. So if 7 times 4 is 28, and 7 times 5 is 35, can 32 be a factor of 7? No. And then now we have 8. So we already know. We've got all of them. Because what we're going to be doing when we factoring is we're going to be doing this thing called rainbow factoring, which is where we're meeting our factors, and then once we get to the middle, we don't have to keep going. So there's 2 ways to think about factoring. What can you multiply together to get that number? So 32 is our number. We're trying to figure out our factors by figuring out what can we multiply together to get 32. Well, 1 times 32, 2 times 16, 4 times 8. So again, 1, 2, 4, 8, 16, 32 are our factors. There's also another way. What numbers can you divide evenly into 32? So what can you divide 32 by to get an equal number? Well, 32 divided by 1 is 32. 32 divided by 2 is 16. 32 divided by 4 is 8. 32 divided by 8 is 4. 32 divided by 16 is 2. 32 divided by 32 is 1. So those are two ways to try to figure out, okay, what are my factors? Now another thing we're going to be talking about today are multiples. What are multiples? Zadie.
The product of a given number and another factor multiplied together.
Good. So when you're trying to find the multiple of a number, you're taking that number and you're multiplying it by something else to get an answer. Whatever the answer is, those are your multiples. So the multiple of 4 times 9 is 36. If we were wanting to find the multiples of 4, we would just start figuring out, okay, 4 times blank is blank. So we would start, they don't have it on here, but we would start with 4 times 0. 4 times 0 is what, class?
0.
0. So there's the first multiple of 4. Then we would say 4 times 1 is,
4.
4 times 2 is,
8.
4 times 3 is,
12.
4 times 4 is,
16.
4 times 5 is,
20.
4 times 6 is,
24.
4 times 7 is,
28.
4 times 8 is,
32.
4 times 9 is,
36.
36.
so that means 0 because 4 times 0 equals 0. 0, 4, 8, 12, 16, 20, 24, 28, 32, 36, and so on are multiples of 4. Because we could keep going, right? We could do 4 times 10, 4 times 11, 4 times 12, 4 times 13, 4 times 156, and all of those answers would be the multiples of 4. So if you're trying to find the multiples of a number, you're going to multiply it by other numbers and find the answers. The answers are the multiples. The pieces of the problem are the factors. So what we're going to do today is we're going to find factors and multiples of certain numbers. Now, this sheet on the back, let's look at it really quick. Okay, so now let's look at this sheet. Is it a factor? I only see like 3 people in the classroom that are actually looking at this. Aaron, does that look like this? And I said, turn it to the back. Okay, so this says, is it a factor? This will help you decide if numbers 1 through 11 are factors. So let's look at number 1. 1 is always a factor because you can always multiply 1 times a number to get that number. 1 is always a factor because no matter what number, if I have 9, can I multiply 1 by anything to get 9? What can I multiply 1 by to get 9? Carla?
9.
9. If I have 127, can I multiply 1 by anything to get 127? Smith?
Yes.
What can I multiply 1 by to get 127?
127.
127. Because of that identity property of multiplication, any number times 1 is itself. 1 is always a factor. 2. Is 2 a factor? Well, is the number even? Does it end with 0, 2, 4, 6, or 8? Then 2 is a factor. If it does not, if it ends with 1, 3, 5, 7, or 9, 2 is not a factor. It is odd. So 3. Is 3 a factor? If you add the digits together, is the sum a multiple of 3? So for example, we have 42. Well, if we take those digits and add them together, 4 plus 2 is 6. Since 6 is a multiple of 3, you can multiply 3 by something to get 6. That means 3 is a factor of 42. Number 4. Is 4 a factor? Well, if 2 is a factor, aka if it's even, and the other factor is even, that means 4 is a factor. So if you figure out that if it's even and you multiply 2 by an even number, that means that is a factor of 4. Number 5. Is 5 a factor? Well, does it end in 5 or 0? If it ends in 5 or 0, it is a factor. If it does not end with 5 or 0, it is not a factor. Is 6 a factor. If 2 and 3 are both factors, then 6 is also a factor. Is 7 a factor? Well, you have to think of your 7 times tables, like 0 through 12. If it's a factor of 7, if it's a part of the 7 times tables, then it is a factor. Number 8, was 4 a factor, and is the other factor even? So if 4 is a factor and you're multiplying it by an even number, then 8 will be a factor. Is 9 a factor? Well, was 3 a factor, and was the other factor a multiple of 3? So if you can multiply 3 by a number that is a multiple of 3, then 3 will be a factor. Is 10 a factor? Well, does it end with 0? If it does not end in 0, 10 is not a factor. If it does, 10 is a factor. Is 11 a factor? Well, is it a mirror? Like 11, 22, 33, 44, 55. Then 11 is a factor. Now, these don't work for every single number because obviously once you get past 99, there are no more that are mirrors. Because mirrors are just 2 digits. You may have 111 and 222, but those aren't necessarily factors of 11. Okay, so that's just helpful for smaller numbers. This may not be as helpful for larger numbers, but it will help you with smaller numbers. Okay, so let's go ahead, open your math book to page 173. Okay, so everybody, finger or pencil on example 1. Now make sure that you are paying attention to this lesson. This lesson will not take you long if you are paying attention and you are following along so that you can do those same steps yourself. If you are not paying attention and you are not listening to my tips and my tricks and showing you how to do it, this lesson will take you a very long time to complete on your own. So make sure that you are focusing and paying attention. Everybody, finger or pencil on example 1. I would prefer your finger or at least your pencil holding. Your hand holding your pencil. Not just your pencil laid on your book because that's not really making sure you're in our spot. Quickly, please. Quickly, please. Okay, we have to move on. You need to catch up with us. Read example 1 in your head while I read it out loud. Remember, we're not going to try to find important information until after we know the question. Mrs. Navarro is arranging desks in her classroom. There are 12 desks. How many ways can she arrange the desks so that the number of desks in each row is the same? So here's our question. How many ways can she arrange the desks so that the number of desks in each row is the same? That means no matter how many rows she has, the number in the columns are the same. So what we have to do, we know there are 12 desks. Other than that, do we know another number to multiply it by? Carla?
No, we don't.
No, we don't know what to multiply. We don't know what to divide. We can also see that we're not trying to get anything bigger than 12 because she's just trying to figure out how many ways she can arrange the desks. So is she ever going to end up with more than 12 desks? No. Is it asking us how many are going to be in each row? Is the question asking us how many desks will be in each row? Zadie?
No.
No. So we're not really trying to figure out what do we multiply or divide 12 by. What we're trying to do is we have to break down or decompose 12 into its factors. So underline break down or decompose because that's what it means. We're going to take 12, we're going to break it down, figure out what are 12's factors. That's what decompose means. Decompose means to break down. think of factors that result in a product of 12. So that means we're thinking of numbers that when we multiply them together, the answer is going to be 12. Then we're going to use the factors to write a number sentence for the arrays shown. Now first, what I want to do is I want to figure out what my factors are. This is a way, well, no, let's do this and then we'll do this the other way. So here are my 12 desks. Remember, arrays are when we take the columns and we multiply them by the rows. So in this array, let's look at the rows first. How many rows do we have? Victoria. In this very first array, how many rows do we have? 1. Because remember, rows go side to side. Like you wouldn't plant seeds right on top of each other, you plant them in a row. Next, side by side. Now, Victoria, how many columns do we have? Remember, columns are up and down. Otherwise, when you see columns on a building, they wouldn't hold up the roof. You have it in your book, so you don't have to try to strain to see what's up here. How many columns do we have, Victoria? 12. We have 1 row, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 columns. Well, how many desks do we have in all? We have 1 row of desks and 12 columns of desks, and in all we have how many desks? 12. Now let's look at this array. How many rows do we have in this second array, Smith?
2 rows.
2 rows. 1, 2. How many columns do we have in this array?
6.
6. 1, 2, 3, 4, 5, 6. Does that change the number of desks we have, Smith?
No.
Because we still have how many desks?
12 desks.
12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now this third array. Zadie, how many rows do we have?
3.
3. 1, 2, 3. And how many columns do we have, Zadie?
4.
4. 1, 2, 3, 4. Does that change the number of desks we have?
No.
No, because we still have how many?
12.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, are there any other ways we can arrange these desks other than doing columns or rows of 1, 2, 3, 4, 6, or 12? Are there any other ways that we can arrange these desks so they have the same number in each row? Can we put them in 5 rows or columns? Can we put them in 7 rows or columns? Can we put them in 8 rows or columns? Can we put them in 9 rows or columns? Can we put them in 11 rows or columns? And we already know we can put them in 12 rows or columns. So that means the factors of 12, and I'm going to do this, I'm not going to put 1, 12, 2, 6. I'm going to put least at the beginning, greatest at the end, because that's how you arrange factors when you're writing the answer. So my factors are 1, 2, 3, 4, 6, and 12. Now there are some other possible arrays, but I'm not going to use any new numbers because I could put it in 12 rows with 1 column. 12 times 1 is what, class?
12.
12. I could put it in 6 rows with 2 columns because 6 times 2 is what, class?
12.
12. I could put it in 4 rows with 3 columns because 4 times 3 is
12.
12. Now what tells us that these are other arrays? What tells us that these are other arrays for these numbers? Victoria. So what is that? What tells us that if we switch the order, it still gives us the same answer? What is that called? That tells us no matter what the order of the factors, the answer will be the same. Aaron. The commutative property. So now we have to figure out the answer to the question because we have the factors, but we haven't figured out the answer to the question. How many ways can the desks be arranged? Well, let's count the arrays. 1, 2, 3. Are those the only arrays? What are the other arrays? How many more arrays can we put them in? Colin? 3 more. So we have 1, 2, 3, 4, 5, 6. So there are 6 ways that the desk can be arranged. Without having to make arrays, we can also tell how many ways it can be arranged by counting the factors. We have 1, 2, 3, 4, 5, 6. However many factors a number has, that's how many ways you can arrange it, how many arrays you can make. Because you can always start with that many rows. Now, here is another way. This is called factor rainbowing. So if I want to find the factors of 12, I can make a factor rainbow. So you can go ahead and do that in one of these empty spaces. Don't make it huge. Make sure you're copying exactly what I have on the board. Do not make it huge, otherwise you won't be able to see it, and you're not going to be able to see the image of what it looks like. So we always know the first factor of every single number is 1. The first factor of every single number on the planet is 1, because you can always multiply 1 by something to get a number. We know that because of the identity property of multiplication. We always know the last factor of every single number because whatever the number is also a factor. So we know the first factor of 12 is 1. The last factor of 12 is 12. Notice how I have space between them. It's because I'm making a factor rainbow. Now it's an upside down rainbow because what I want to do once I figure out those factors is I'm going to connect them. Because that shows me, hey, I've already figured out the factor pair for that number. Now I'm just going to keep going in order. I'm going to figure out, okay, is 2 a factor of 12? Well, let me see. Is there anything I can multiply 2 by to get 12? Yes. 2 is a factor because I can multiply it by 6. So I'm going to meet those factors. There's the next layer of my rainbow. Now I'm going to keep going, number by number. Is 3 a factor of 12? Well, let me think. Can I multiply 3 by anything to get 12? Yes. I can multiply 3 by 4. Now normally, I would go to the next number. 4 comes after 3, but I see I've already got it. So do I have to do it again? No, I already know 4 is a factor of 12 because I matched it with 3. Once I meet the other side of my rainbow, I can stop. Because as long as I did the front of my rainbow correctly, once they meet, I'm not going to have any more factors. So I've already met because I've got 4. I'm not going to keep going. I know it's not 5 because there's nothing over here that can match it. I know there's not 7 because there's nothing over here that can match it. And I know there's not 8, 9, 10, or 11 because there's nothing over here that can match it. Let's look at a bigger number. Before we move on, let's look at a bigger number that has more factors. Let's see. Let's do 42. Factors of, no, not 42. It's a good one. 36. Factors of 36. What is my first factor always, no matter what? No matter what the number is, what is always my very first factor? Michaela? 1. And what is always going to be my last factor? 12? 36. Whatever the number is will always be my last factor because whatever the 1 matches with is always the number that we're finding factors for. Now 2. Well, I have to think, is there anything I can multiply 2 by? Well, I know 2 times 12 is 24, and this is bigger. But that's where this sheet comes in, because is 2 a factor? Well, is the number even? Is 36 even or odd? Class. Is 36 even or odd? Class.
Even.
Even. If you don't know even or odd, I don't even know. You need to go to the first grade IXL and you need to do the even or odd. That's all I can tell you. If you don't know what even or odd is, because we don't have time to do that whole lesson. I mean, that's a first grade lesson. 36 is even. So that means 2 has to match with something. Now I don't want to move on to the next number until I figure out what 2 matches with. Well, I know 2 times 12 is 24. So that means I have to think, okay, 2 times 13. Well, that means repeated addition. 3 plus 3 is 6, so it's not that. Is it 14? Nope. Is it 15? Nope. Is it 16? Nope. Is it 17? Nope. Is it 18? Yes. So that means 2 matches with 18. So that means 18 is also a factor of 36. Now what comes after 2? 3. Is 3 a factor of 36? Well, if I think about it and I think about my basic facts, I know that there is a basic fact that has a 3 in it for 36. Because 3 times 12 equals 36. Now I have to think of 4. Well, 4 times something. Is there anything I can multiply 4 by to get 36? Victoria? 9. Oops, I forgot my rainbow piece. So 4 times 9 is 36. Next comes 5. 5 times anything. Well, I know 5 times 7 is 35, and 5 times 8 is 40. 36 is between 35 and 40, so 5 cannot be a factor. Now I need to think of 6. 6 comes next. Well, let's think of my 6 times tables. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 6 is 36. Now I'm not going to do 6 over here because I'm not going to list a factor twice. I basically just have a very tiny little rainbow piece. Now, I've met in the middle, right? Because 6 times itself is 36. So do I have to keep going with 7 or 8 or anything like that? No, because I've already met in the middle. And as long as I did the first half of my rainbow right, the last half is also correct. So that's called factor rainbowing. That's a really good strategy that we will use when we get to the guided practice because it will make sure that you haven't skipped anything. Now sometimes this does mean you might have to do some repeated addition. Or once we get more comfortable with doing multiplication with 1-digit numbers, you may have to do that. Okay, so for now, let's move on to example 2. Helper number 1. Let's look at the top of page 174. Kingston, please read loudly and slowly. Louder. Louder.
A multiple of a number is the product of that number with any whole number.
Pause. So a multiple of a number is the product of that number that you're trying to find the multiples for and any other whole number. So that means it's the answer when you use that number in a multiplication problem. The multiple is the answer. The factors are the parts that make up the problem. So make sure that you are finding the correct, that you are paying attention to which word it's asking for, because I've seen this every single year. The question will ask for factors and somebody will list the multiples. Or the question will ask for the multiples and somebody will list the factors. So make sure that you are paying attention. The factors of a number are the numbers you multiply together to get that number. The multiples are the product of using that number multiplied by anything else. So, keep reading, Kingston. Stay loud.
For example.
Louder.
For example.
A little louder.
For example, 15 is a multiple of 5 because it is composed or made of 3 groups of 5. 15 is also a multiple of 3.
So 15 is a multiple of 5 because 5 times 3 equals 15. 15 is also a multiple of 3 because 3 times 5 equals 15. So everybody, finger or pencil on example 2. Scoot your chair in. Read in your head while I read out loud. All of the numbers listed in row 7 or column 7 are multiples of 7. Shade the multiples of 7 on the chart. So that means we're finding row 7. Everybody put your finger on where row 7 starts. Remember, rows are side to side, columns are up and down. So find where row 7 starts. Ethan, pay attention. Find where row 7 starts. Zari, I'm not sure what you're doing, but you're not following directions. That is you're losing points on your homework because that's the only consequence I can give. You've had that consequence before. Let me go make a note to myself. Okay, so everybody's finger should be on where row 7 begins. Row 7 begins right here. Now, put your finger on the place where column 7 begins. Don't take your finger off row 7, so use your other hand to put your finger on the place where column 7 begins. So one hand should be where row 7 begins. One hand should be where column 7 begins. All of those numbers in this row, in this column, are multiples of 7. That means you can multiply 7 by something to get each of those numbers. 7 times 0 is 0. 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. 7 times 6 is 42. 7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 63. 7 times 10 is 70. Same thing here. 0 times 7 is 0. 1 times 7 is 7. 2 times 7 is 14. 3 times 7 is 21. 4 times 7 is 28. 5 times 7 is 35. 6 times 7 is 42. 7 times 7 is 49. 8 times 7 is 56. 9 times 7 is 63. 10 times 7 is 70. So go ahead and quickly shade every number in row 7 and every number in column 7. You're not going to stop where they meet because that's not where the multiples end. They keep going in both the row and the columns. So you should be shading row 7 and column 7. And then put your pencil down when you're done. Make sure you're not doing it so dark that you can't see the numbers. so the first 5 multiples of 7 are 0, 7, 14, 21, and 28. We can see that here too. The first 5 multiples are 0, 7, 14, 21, and 28. 28 is a multiple of 7 because it is composed of how many groups of what? 28 is a multiple of 7 because there are how many groups of what number? Okay, I need you guys, it's not taking this long to write it, so don't act like you're still writing, and that's why you can't answer the question. 28 is a multiple of 7 because it is composed or made up of how many groups of what? Colin.
4 groups.
I can't hear you.
4 groups.
Of? How many? How many are in each of those groups? There's 4 groups. How many has to be in each of those groups to make 28? 7. 28 is a multiple of 7 because it is composed of 4 groups of 7. We could also say 28 is a multiple of 7 because it's composed of 7 groups of 4. Okay, so now let's look at the guided practice. Okay, so let's look at the guided practice, and let's look at number 1. The directions for numbers 1 and 2 say find the factors of each number. So we're going to do our factor rainbows. So first, you can do that right here. We're going to find the factors of 6. Carla, you're going to help me out. What is the first, we're going to make our factor rainbow. What is the first factor of every single number?
The first factor of 6 is 1.
1, very good. Now we have to meet it on the other side of the rainbow. 1 times what equals 6?
6.
6, very good. Now, let's think of 2. Well, is 2 a factor of 6? First of all, we can look at the number. Is it even or odd, Carla?
It is even.
Even. So that means 2 has to be a factor, right?
Yes, ma'am.
Yes. So now let's figure out, okay? 2 goes with what? Well, 2 times what equals 6, Carla?
3.
3. Now, normally we would go to 3, but look, we already met in the middle with 3. So do we need to keep going, Carla?
No.
No, we've already met because what comes after 2 is 3. We've already got it in our factor rainbow, so we don't have to keep going. So that means, what are the factors of 6, Carla, in order from least to greatest?
1, 2, 3, and 6.
Very good. Now we have to figure out the factors of 36. So you have this big area right here. We're going to make another factor rainbow. Now I know we've already done this one, but we're going to do it again because practice never hurts. So, let's start our rainbow. Zari, what is always the first factor of every single number?
1.
1. Now we have to meet it on the other side. Make sure you're not working ahead, Zari, because then you won't have this factor rainbowing, which means when we get to bigger numbers, you're not going to know. You're going to skip a lot of factors. Okay, so we have to match it on the other side because we have to make our rainbow. 1 goes with what number? 1 times what will equal 36?
1 times 36 equals 36.
Good. Now, what comes after 1, Zari?
2.
2. So we have to figure out, is 2 a factor of 36? Well, first let's look. Is 36 even or odd? Zari, is 36 even or odd? I can't hear you. I think your microphone got turned off. Because you're not muted. I think your microphone got turned off again. So go check it. If you're turning it off, you need to make sure you're not doing that. So Zari, is 36 even or odd?
Odd.
What does 36 end with? Zari,
6.
is 6 an even or an odd number?
Odd.
Okay, Zari, you need to work on evens and odds. Kingston, is 36 even or odd? Even. Remember, Zari, if it ends with 0, 2, 4, 6, or 8, the number is even. So we know 36 is even, which means we know 2 has to be a factor, but we have to meet it on the other side. Well, there is no basic fact with 2 that equals 36, so that means we may have to do some repeated addition. We already know earlier, because we did it earlier, 2 times what equals 36, Zari? Zari, 2 times what equals 36? You're muted. We did it earlier. You're muted now.
18.
18. Okay? 3 comes after 2. Well, let's think. Is there anything we can multiply 3 by to get 36? Zari, is there anything we can multiply 3 by to get 36? You're muted. Is there anything we can multiply 3 by to get 36? You need to be working on your basic facts if you're not able to say this off the top of your head. You're still muted. Sorry, I'm going to have to call on somebody else if you're not going to pay attention to what you're doing. Okay, I'm going to have to call on somebody else. Aaron. Is there anything we can multiply 3 by to get 36? Yes. 3 times what equals 36? 12. Now what comes after 3, Aaron? Is there anything we can multiply 4 by to get 36? No. Are you sure? Think of your 4 times tables. This is why you guys have got to know your multiplication facts. 9. 4 times 9 is 36. Okay, Aaron, what about 5? Is there anything we can multiply 5 by to get 36? No. How do you know? I need to know why 5 cannot be a factor of 36. Think about your 5 times tables. 5 times, so what? 5 times what gives us a number right before 36? This is, you guys have got to study. And just because you're looking back doesn't mean you know why. 5 times 7 is what, Aaron?
35.
Louder.
35.
5 times 7 is what? 5 times, and then 5 times 8 is what? Wait, I'm sorry. Yeah, 5 times 8 is what? 40. So if 5 times 7 is 35 and 5 times 8 is 40, is 5 times anything 36? So 5 is not a factor. Well, now 6. Is 6 a factor of 36? Think of your 6 times tables. You guys have got to learn. You've got to memorize your times tables. If you think it's hard now, when we get to the next lesson, that's all you're doing is basic facts constantly, but you're doing like 6 in one problem. Aaron, is 6 a factor of 36? Can we multiply 6 by anything to get 36? Think of your 6 times tables. 6 times 1 is what? 6 times 2. It's 12. 6 times 3. Okay, this is why we have to keep doing drills. Colin. 6 times 3.
6 times.
Without looking at the
6 times 3 is 18.
6 times 4.
27.
Victoria, 6 times 4.
24.
6 times 5. 6 times 6. So is 6 a factor of 36? Yes. What do we multiply 6 by to get 36? 6. So our rainbow has met. Use these factor rainbows, but the factor rainbows won't help if you don't know your basic facts. This is why we're going to start with drills again tomorrow. Okay, so that means, Victoria, what are the factors of 36 in order from least to greatest?
1, 2, 3, 4, 6, 9, 12, 18, 36.
36. Okay. Keep studying. We're going to have another drill tomorrow. Every single person is going to do it until everybody gets an A. I'm only going to be scoring the ones who don't have an A yet. So that means if you already have an A and you don't feel like practicing one day, you should practice. But you can just sit there and do nothing. But if you don't have an A yet, I'm going to be scoring it, which means it's going to be put in Power School and it's going to go home to your parents. Okay, now for numbers 3 and 4, we have to identify the first 5 multiples. So that means we're not figuring out the numbers that we can break this number down into. We're figuring out, okay, what are the answers if we multiply this number times another number? So Colin, number 3 is 4, where we're just going to count by 4s, starting with 4 times 0. 4 times 0, loud so everybody can hear you. 4 times 0 is 0. Okay, what's the next one? 4 times 1 is?
4.
4. 4 times 2 is?
18.
4 times 2 is? You told me
8.
18.
8.
8. Come on. 4 times 3 is?
12.
And 4 times 4 is?
16.
16. So there's our first 5 multiples of 4. 4 times 0 is 0. 4 times 1 is 4. 4 times 8 is 2. 4 times 3 is 12. 4 times 4 is 16. Okay, number 4. We have the number 9. Michaela, we need to list the first 5 multiples. So we're going to start with 9 times,
0,
which is,
0,
then we do,
9,
which is
9,
loud so everybody can hear you. Then we do,
9 times 18.
we did 9 times 0, 9 times 1, 9 times
8.
9 times 0, 9 times 1, 9 times
2.
2, which is,
18.
then we do 9 times 3, which is,
27.
then we do 9 times 4, which is,
36.
ooh, I can tell somebody really worked on their multiplication facts over the break. So we have 1, 2, 3, 4, 5. So the first 5 multiples of 9 are what, Michaela? Loud so everybody can hear.
0, 9, 18, 27, 36.
Very good. Okay. Let's see, it's about time to start reading, but because we're starting Wonder today, the lessons aren't as long. So what we're going to do is I'm going to give you we're going to do one of the independent practice factoring together so that we can do some factor pairs. So everybody go ahead and get out a separate sheet of paper because I'm going to need to see the factor rainbowing for every single number, which means on your homework, what are you going to have to show for every single problem that asks for factors? Smith.
A factor rainbow.
A factor rainbow. Very good. Okay, so we're showing number 9 on a separate sheet of paper. What is the first factor of every single number?
1.
1. Then we have to meet it on the other side. 1 times what is 30?
1 times 30 equals
1 times 30 is 30. Okay, now we have to think, is 2 a factor? Well, I know there's no basic facts, 2 times this, because 2 times 12 is 24, which is less than 30. But I can tell that 2 is going to be a factor of 2 because 30 is what? What type of number is it? What's the first thing we look at to figure out if a number is a factor of 2? Carla.
We will look at the back of it and see if we see 0.
Well, what are we trying to figure out? What type of number? You don't have to tell me all the digits. Just tell me what type of number are we looking for?
Even.
An even number. So is 30 even or odd?
even.
Even. So is 2 a factor of 30?
Yes.
Yes. So now we have to figure out, okay? 2 times what equals 30? Well, let's see. Do we know? So we have to do some repeated subtraction or some repeated addition. So I'm going to go to the side and I'm going to figure out. I know it's not 12. I know it's not 12. Let's try 13 plus 13. 13 plus 13 is what, Colin?
26.
26. That can't be it, right? So now let's try 14 plus 14.
28.
28. That can't be it. So let's try 15 plus 15. What's 15 plus 15, Colin?
30.
30. So that means if we added 15 twice, that means 2 times what equals 30?
15.
15. Okay, now next comes 3. Is 3 a factor of 30? Is there anything we know we can multiply 3 by to get 30?
Yes.
Yes. 3 times what equals 30?
10.
10. Now we have to think of 4. Is 4 a factor of 30? Is there anything we can multiply 4 by to get 30? So think of your 4 times tables.
No.
No, because 4 times 7 is what?
4 times 7 is
Zari?
21.
Nope. Michaela? 28. You guys have got to get this. And 4 times 8 is what? Michaela? What's 4 times 8? 4 times 7 is 28. 4 times 8 is? Colin?
32.
So that means 4 times 7 is 28. 4 times 8 is 32. So is 4 a factor of 30?
No.
What about 5?
Yes.
5 times what equals 30?
5 times 6.
5 times 6. Now our next number is 6, but we've already met in the middle. So do I have to keep going?
No.
No. So what are my factors of 30 from least to greatest?
1.
Remember, we're on number 9. We're on number 9. So 1,
2.
2,
3.
3,
5.
5,
6.
6,
10.
10,
15.
15,
30.
30. Okay, so make sure you show that factor rainbow. So now I'm done with that. So I'm going to draw a line, and then I'm going to start with number 5 right below. Factors of 4. And then I'm going to do my factor rainbowing. So right now, I'm going to give you 13 minutes to work on your independent practice. You'll have more time later today, but for now you have 13 minutes. Make sure that you are showing your factor rainbowing on your separate sheet of paper. Do not do it on this sheet. Do not do the factor rainbowing. You must show the factor rainbowing for independent practice and homework. So that means, what do you need to bring home with you tonight along with your homework, class?
A separate sheet of paper.
A separate sheet of paper. Okay, so go ahead. You have about 12 and a half more minutes. You can use this sheet to help you, but remember, you have to list the factors in order from least to greatest. You can't skip factors. So this alone will just tell you, okay, so that means I need to figure out what to multiply by to get this number.